Hello everybody and welcome back. Root Beer here, looking at question number 3 on our 2014 Galois paper. Cards in a deck are numbered consecutively with positive integers. The cards are selected in pairs, A, B, with A always less than B, so it's a nice forced little order there, to create a given sum, A plus B. For example, Anna has a set of cards numbered from 1 to 50, and she is required to create a sum of 60. Two of the pairs that she can select, but not necessarily has to or anything like that, are 10 and 50, because those add up to 60, and 25, 35. Okay. So we've got 3 light bulbs and a written, and we can, as with all these sort of Friar Galois Hypatia questions, you can try and read everything all together and see if maybe you're headed towards a certain sort of general result. Usually that happens with questions 4, but it can happen with questions 2 and 3. Or you can just sort of take these one at a time and calculate. So I'll start with that, but if I start sort of thinking that something might be up or that there's a deeper bit of theory to develop, we'll take some time to do that. Alright, so first light bulb. Emily has a set of 10 cards numbered from 1 to 10. There are exactly 3 pairs that she can select, having a sum of 8. List the 3 pairs. Okay, so we need a sum of 8. So we could do 1 and 7, 2 and 6, or 3 and 5. Notice we can't do 4 and 4 because there's only one 4 in the deck. That might be important if we're ever asked to count the number of ways to make, say, 50. You can't do 25, 25, so you could only have 24 ways to do 50, for example. And that's assuming that you have 49, because you'd need 1 and 49 to make 50. But, okay, there's a... That wasn't too hard. I mean, I really didn't have to do any writing at all, which is fine, because it's a light bulb question. Alright, B. Silas has a set of 10 cards numbered consecutively from 1 to 10, same as Emily. Determine the number of pairs that he can select with a sum of 13. Okay, so we could maybe like make some sort of chart that would actually, that'd be a little big, but I suppose I could say, well, we need to make 13, and we can just do this in a very organized way. There's only going to be so many that we can have for 13. What's the biggest number we could have? Well, 10, because 10 is the biggest card we have. Can we use that to make 13? Absolutely. And now we can work backwards. 9, and then 8, and 7. I'm not saying all of these will lead to a unique pair. Say 4, 3 would be the lowest, because you can't use 2, because you would need 11 for that. But 9 could get paired with 4, 8 could get paired with 5, 7 with 6, and that sort of stops it right there. So there's 4 ways to make 13. And we know there's 3 ways to make 8. That's assuming you have a deck from 1 to 10. Bigger decks, if we had 11 cards, then 2 and 11 would also work here. Alright, C. Daniel has a set of K cards numbered from 1 to K. He can select exactly 10 pairs that have a sum of 100. What is the value of K? So now we're working backwards. I know the number of ways, whereas in the last one we actually had to find the number of ways, and in the first one we were given the number of ways, we just had to find the actual pairs. But now we know the number of pairs that have a particular sum. Can we determine the value of K? So can we work backwards? Is there sort of a connection between, if I tell you it's 1 to n, or I guess 1 to k in this case. If I tell you it's 1 to k and there are m ways to make a sum of n, or m pairs, is there some relationship between k, m, and n? And for all I know, that might be what D is building to, so why don't we read D as we go on. Derek has a set of 75 cards, numbered from 1 to 75. He can select exactly 33 pairs that have a sum of S, determine with justification all possible values of S. So it seems like there is this relationship. So I think I'm going to take, before I do C, I think we probably could do C. You know, 1 and 99, 2 and 98, I think. Oh, no, you'd have to be closer to 100, so you'd have to be 49, 51, all the way to 60 and 40. So I think, I'm just going to predict just from the work in my head that the answer is 60, but I'm actually going to take a little bit of a detour and see if I can find a relationship between K and the number of ways to make a certain number N. So I'll make this part nice and written because we will need it for D. But suppose we have cards 1 to K. I wish to make a sum of N. What N are possible? And in how many ways? So I think 3 is the lowest N can be, because that's 1 plus 2. You can't get any lower because it has to be 2 different cards. And the biggest you could be would be K and then the next biggest number. So 2K minus 1 is the biggest that you could have. And you'll notice there's only one way to do each of those, and I think it's going to sort of like be sort of like rolling a sum of die. Well, of course it's going to be like rolling some die. These are just sort of a K-sided die, and you can't have the same number appear on both die, but it's the same basic idea. What I'm going to do is I'm going to say, all right, put the A's up on top and the B's on the bottom. So we have 2, 3, 4... and then K here. And the A's can be 1, 2, 3, 4. We'll put K minus 1 and K minus 2. And the biggest the A's can be, because there has to be a number that's bigger, would be K minus 3, K minus 2, K minus 1. But I think we're going to get sort of a nice little diagonal pattern if we look at this. So, you know, for example, 3 would be a 1 plus a 2. And then you'd have 4, you'd have 5. But there's another way to get 4, and that would be a 2 and a 2. Well, you can't do that. But you could have a 5 there. 5 and a... So, we're going to eliminate everything that's too high up. Oops. There we go. You can have K and you can have K minus 1 and K minus 2 there. So you get 2 5s. Now with next one, you'd have 5 and 1 would be 6, but you can also get 6 with a 4 and a 2. And then the next one you would have would be 6, and 6 and 1 would be a 7. You can also get a 7 with a 5 and a 2. You can also get a 7 with a 3 and a 4. And so you get this sort of diagonal 3 to get that one, and then, but it's going to sort of peter out eventually, because there's only one way to get 2k minus 1. But there's 2 ways to get 2k, there's only one way to get 2k minus 2, that'd be k and k minus 2. But 2k minus 3 can be done with k minus 1 and k minus 2, but also with k and k minus 3. And so we get these sort of diagonals that work backwards as well. And so there's only going to be 2 ways to make 2k minus 4, whatever the k is. So how exactly does that work? So, the number of ways to make a sum of n is, I'm going to say, the minimum of the following calculation. Okay. So there's 2 ways to make 6, 2 ways to make 5, but only 1 way to make 4. So divide by 2. So if you want 5, divide by 2 and round. Subtract 1, divide by 2, and round down. Subtract 1, divide by 2. We'll use the floor function for rounding down. But the other way is if it's one of these ones. So there's 2 ways to make 2k minus 4. There's 2 ways to make 2k minus 3. So what I want to do is sort of, so I'll say this is 2k plus 2 minus 3. I'm trying to draw a parallel. So you could also do 2k plus 2 minus n minus 1 over 2 and floor function that. And we can clean that one up to be 2k plus 1 minus n all over 2. So that should work. So let's test these out, just because my reasoning with the chart, one, it might not be too clear, so I'd like a way to illustrate this with a smaller example, maybe 1 to 10. But also I want to verify that I really do have these two formulas worked out. So let's look at from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. Try and draw these as straight as possible. I guess I can go slow. So 3, 4, 5, 6, 7, 8, 9, 10. Just barely there. Oh, I don't like that one. Let's see if we can get a bit more straight. There we go. There, getting into a groove now. Alright, so once again, A's on the top, B's on the bottom. Now, you can't do 1 and 1. Can't do 2 and 2, 3 and 3. And in fact, anything above so that's all out. Alright, but we can do 1 and 2. That's 3, 4, 2 ways to do 5, 2 ways to do 6. There's 1 way to do 19, which is 2 times 10 minus 1. There's 1 way to do 18. There's 2 ways to do 17, 2 ways to do 16. 3 ways to do 15. 3 ways to do 14. 13 is a 5 and an 8, or, yeah, actually we have these 4 ways to do 13. That's what we answered in an earlier question. So 7, 7, 7, 8, 8, 8. So there's a full sort of version of the chart that I'm trying to create, and I'm just saying, well, it's just, you're only ever going to get these numbers on diagonals. Everything's shifted ever so slightly. So you get 1, 1, 2, 2, 3, 3, 4, 4. And coming the other way, you get 1, 1, 2, 2, 3, 3, 4, 4. And 11, quite curiously, is there's 5 ways to do it. Now, let's check our calculation there. So, 11 minus 1 over 2, floor function would be 5. And then, what was it? It was 2k plus 1. So, that'd be 21 minus 11 over 2. And that would also be 10 over 2, which is 5. So, okay, good, that makes sense. 12 minus 1 over 2 would be also 5. 21 minus 12 over 2, that would be 9 over 2, which would be 4.5, round down to 4. And there are 4 ways to do 12. Okay. This is working out quite nicely, I would say. Is it always I feel like it is always just going to be this one middle one, no matter where you stop. Because of course, if I just look at sort of this part, this would be doing it from 1 to 3, and that would mean 5 only has one way. Is that actually accounted for in my work? And the one that appears the most is always k plus 1. Is that the unique one that always appears the most? Yeah, actually it is. But 5, so if I was doing 3, so if k was 3 and n was 5, I'd have 5 minus 1 over 2 floor function. Now that should be 2, but we could also have 3 times 2 plus 1, so that's 7 minus 5 over 2 floor function. That would just be 1. So, okay. Good, I'm happy with that stuff now. So, I've got this relationship. I've explained my relationship. I've got a little picture. You know, maybe it could be a little clearer where it's coming from. But now I can use it to answer my questions. Now, what have we got? We know for C, we're doing 1 to k, and 100 can be made 10 times. So, I know that either 100 minus 1 over 2, well, that's always going to be 99 over 2 is 49.5, so it's going to be 49. Well, that's not 10. So, therefore, so this is not 10. So, therefore, 2k plus 1 minus 100 over 2, floor function, needs to be equal to 10. Okay. Now I have options here. They say, what is the value of k for C? So do I really have options? So 2k plus 1 minus 100 over 2 is either equal to 10 or 10.5. Oh, but only one of them is going to be odd. So 2k plus 1 minus 100 is 20 or 21. So 2k plus 1 is 120 or 121. That one's impossible. So 2k plus 1 must be 121. 2k must be 2k must be 120. So k is 60, which is what I predicted. We can even sort of double check this. 40 and 60 would be 141, 59, 42, 58. You get the idea, but I'm almost halfway there, so we'll finish this off. 44, 56, 43, 45 and 55, 46, 47, 48, 49, but not 50. And so if I even had a 61, obviously I'll have card 39, and those would add up, and that would be more than my 10 pairs there. So yes, 60 is the answer. But now, having developed our theory earlier, we can move on to D. And what that was D, 1 to 75. So K is 75, 33 pairs having a sum of S. Oops. Wrong button. Okay, so for D, K is 75. And 33 is the minimum of S minus 1 over 2, floored, and 2K plus 1 minus S over 2, floored. But I know what K is. So 33 is either the minimum of S minus 1 over 2, and 2 times 75 is 150, so 151 minus S over 2. Okay, so I'm predicting that the most we could have here, and maybe there's 4 ways to do it. They're not asking for how many different, but I think there's at most 4 different values of S. Just like if we go back, there's 1, 2, 3, 4 different sums that are only expressed once. There's 5, 6, 17, and 16 that are expressed twice. Maybe 33, maybe 75 is big enough that 33 has 4 different ways to do it. Or it could be like if we cut it off at 3 and then each one has only 1 possibility. So there's options here. There's definite options. But, okay. So, well, each of these is going to lead to a different S. So, let's say, suppose we got S minus 1 over 2, floored. So then 33 is either S minus 1 over 2, or 33.5 is S minus 1 over 2. Okay, so that would be 66 is S minus 1, or 67 is S minus 1. And so S is 67, or S is 68. So those are 2 possibilities, although with 75, I feel like these numbers will, their minimums will get smaller. In fact, with 75, let's see, with 10, the most we could have was, no, okay, maybe it's possible. The most we could have was 5 different ways to make 11, but 33 is less than half of 75, so that blows that idea out the window. Oh, we're further along, aren't we? Okay, suppose instead, well, each of these should be able to be ruled out. So 151 minus 67, right? Yeah, 151 minus 67 over 2 floored. Is that less than 33? I don't know. So 151 minus 67, so that would be 91 minus 7, so that would be 84. 84 is, that'd be 42. 33 is the smaller of the 2, so that works. How about 151 minus 68 over 2? That would be 83 over 2, and that would be 41, so 33 is still the smaller. That works. Okay, so 67 and 68 are definitely possibilities. How about the other pair? So suppose 151 minus S over 2 is equal to 33. Then, because we're dividing by 2, either 33 is equal to that division and it's an even number, 151 minus S is an even number, or 151 minus S is odd. We divide by 2, we get 33.5, which rounds down to 33. So either 151 minus S is 66, or 151 minus S is 67. We just did that one, so 151 minus 67 is S. S is going to be 84. Or S is going to be equal to 85. Okay. So if S is equal to 84, well, we just did that one a moment ago, sort of. S minus 1 over 2, that'll be 83 over 2. And that'll be 41. Did I write 43 over here? No, I did write 41. And 33 is the smaller of those 2 numbers. And then S minus 1 over 2 here would be 85 minus 1 is 84. 84 over 2. And we're going to get 42. 33 is the smaller of those numbers. So S can be either 67, 68, 84, or 85. Those are my possible answers, and you can see they're sort of evenly distributed around the 76. 76 is, this is just off to the side, is the most common. With, it should be 75, or 75 over 2. Oops. No, that's not my eraser tool. So 75 minus, no, I'm already doing 76 minus 1. Let's just write that. 76 minus 1 over 2 would be 75 over 2. So that'll be 37.5, so that'll be 37. And if I did it the other way, 151 minus 76 over 2 will also be 75 over 2, so same number. So that happens 37 different ways. So if we wanted sort of a mental picture, we'd have 3 and 4 and the 2 5s. And then down here we'd have 149 and 148 and 2 ways to get 147. And then we'd get 76, 76, so many 76s. And then somewhere up here we'd get 68, 68, 33 of them. 67 would also be paired. And up here we'd get 84 and some 85s. There we go. Nice little question. I like the sort of addition tables that I made. Might be another way to do the question, but I like it. I also like these formulas. We did take some time to develop them and double check them, which is most important. If you think you got a formula, if you think you understand a phenomenon, usually the way these questions are set up is that the earlier parts sort of give you data and information. The light bulbs can give you simpler cases that you can then plug into your formulas. So good question overall. I can't wait to see what question 4 has in store for us. We'll finish off our 2014 Galois in the next video.